Here's another question. To calculate the sum of all moments about point A. This is point A. So first of all, we need to define the forces and their perpendicular distances. So if we come to the first force, which is F1, this one. So this one is the force is 15. So for F1, if the value is 15, and let's see what is the perpendicular distance. What is the perpendicular distance to this one between the force F1 and point A? And we can clearly see the distance is from here to here. This is the perpendicular distance, so this is the first element for our moment. Moment needs to have a force and perpendicular distance. So for this one we have a perpendicular distance, yes. Now for F2, and F2 is, this is F2, and for F2, what is the perpendicular distance? This is the perpendicular distance between F2 and point A. So do we have a perpendicular distance for this one? The perpendicular distance for this one, yes, we do have one, and it is equal to 12 meters, and for this one is equal to 15.59 meters. Now let's come to the third force, which is F3. So for F3, do we have a perpendicular distance? In reality, if you look at F3, there is no perpendicular distance between F3 and point A, because F3 is passing through point A, so there is no perpendicular distance for this one. So we'll say that for F3 there is no perpendicular distance. So now we have defined the forces and their perpendicular distances. Next step is that let's see how the force F1 is rotating about point A. So force F1 is rotating in this way about A, and this is counterclockwise, so it is positive. And for F2, F2 is rotating in this direction about A, and that is clockwise, so it is negative. And of course we said F3, it is not causing any rotation because it is passing through the point. It is passing through the point, so it will cause no rotation. It might cause pulling, but it is not causing any rotation. So now let's move to the calculation. Now let's do the calculation. Now that we know the F1 has a perpendicular distance, so it will cause rotation counterclockwise, and F2 has also a perpendicular distance of 12 meters and will cause a rotation that is clockwise, and F3 doesn't have any perpendicular distance to cause a rotation. So let's start the calculation. So for the first force, which is F1, so let's do F1. So F1 is equal to 15 kilonewton, and the perpendicular distance for F1 is the 15. So here we go, it is 15.59 meters. And what is the type of rotation? It is rotating counterclockwise, so it is positive, so it is doing this rotation, it is positive. Now let's go to the F2, and F2 is 30 kilonewton. This is F2 per kilonewton, and this F2 is rotating clockwise, which is negative. So it is negative and has a distance of 12 meters. So this 12 meters is a distance. And for F3, which is 12 kilonewton, it has no distance and causes no rotation. So let's come to the calculation. So we'll do the calculation for, we say the sum of moments about point A is equal to how much? So we'll say we have the first one, F1 is positive, so it is plus, and we remember the definition of moment, which is force multiplied by perpendicular distance. So F1 is equal to 15 kilonewton. I prefer to use units because at the end you will see the units for the end result. So 15 kilonewton is the force, and the distance is 15.59 meters. And F2 is negative, so it is minus. The force is 30 kilonewton, and the distance for F2 is equal to 12 meters. And then F3 causes no rotation because the distance is 0, so it is equal to how much? And this will give us a value of 233.85 kilonewton dot meter minus 360 kilonewton dot meter, and the end result is equal to minus 126.15. Now the answer being negative, we know from the sign convention of rotation, so it means this is rotating clockwise, so it means this will cause a clockwise rotation, and the answer is magnitude of rotation is 126.15, and it is rotating clockwise.